A very good morning to Prof. I am Sarvin Kumar. I am going to present regarding sedimentary structure and their significance. As a summary of the topic, sedimentary structure features within sediment rocks offers valuable insight into geological history. Their significance in reservoir quality assessment lies in their ability to reveal past environmental conditions and influence porosity, permeability, and hydrocarbon entrapment. This presentation will explore key structures such as bedding, cross bedding, graded bedding, and mud cracks, and highlight their definitions and examples, and also the significance and implementation of the reservoir quality. As an introduction of my topic, geological structure indicates and helps to reconstruct past environmental and understand the dynamic of sediment deposition. In the context of reservoir quality, sedimentary structures influence critical factors such as porosity and permeability. As the first point of my presentation, which is bedding, bedding refers to bedding refers to the layers of stratificates observed in sedimentary rocks where distinct horizontal layers of different composition or grain size are visible. These layers, known as beds, are formed over time through the accumulation of sediments in variable environment. Example of beddings are siltstone and sandstone beds, which is alternating layers of fine-grained siltstones and coarse-grained sandstone. Next is shale bedding, which is thin laminated layers of mud or shale, often categorized by fine-grained particles. Other than that, limestone bedding, layers of carbonate sedimentary rock composed mainly of calcium carbonate. The significant in interpreting depositional conditions are first environmental changes. Variance or in bedding indicates shifts in the depositional environment. For example, changes from sandstone to shale beds may suggest transitions from high energy to low energy depositional setting. Next is paleocurrent indicators. Beddings can serve as a record of ancient current. Cross bedding within beds may indicate the direction of water or wind flow during the deposition. Sedimentary rates, the thickness and characterize of beddings can provide insight into the rate of sediments. These implication for reservoir qualities are homogeneous or heterogeneous. Homogeneous bedding may suggest consistent porosity and permeability within a reservoir, facilities fluid flow. Heterogeneous beddings can create variations in their properties. Next is the compaction and the cementation. Overburden pressure from successive layers can lead to compensation, reducing pore spaces. Additionally, cementation between grains in bed may affect reservoir quality by alternating their permeability. Next point is the fluid flow dynamics. The orientation or and categorize of the bedding influence the pathway of the fluid flow within the reservoir, and understanding of the bedding is crucial for predicting how fluid will move through the rock matrix. The next point is regarding the cross bedding. Cross bedding is a sedimentary structure categorized by inclined layers of sediment within the horizontal beds. So the example of the cross bedding are alluvial cross bedding, fluvial cross bedding, subaqueous cross bedding. The significant in determining current direction during the deposition is the paleo indicators. The indicator that lays of cross-bedding provides a valuable record of ancient current direction during the time of deposition. Next is the flow dynamic. As I mentioned earlier, the geometrical and orientation of the cross-bedding helps to understand the dynamic of transmission of the medium by water or the wind. Next is environmental interpretation. Crossbedding is an indicative of specific depositional environment. For example, alluvial crossbedding suggests a desert or arid environment, while fluvial crossbedding indicates river or stream environment. The impact on the reservoir qualities are such as entropy definition, which is the permeability. The permeability entropy refers to the direction variation in the ability of the fluid to flow through the rock. Next is enhanced permeability along beds. The next point is reduced permeability across the bed. Next point is graded bedding. Graded bedding is a sedimentary structure categorized by a systematic change in grain size within a single bed. This change typically progresses from a cross grain at the base to a finer grain at the top of the bed. Uh, the example of these graded beddings are turbidite, alluvial fans, and also submarine deposition. These indicating the flow energy variation and sedimentary dynamics and also the environmental changes, which is also implication for the reservoir quality such as the porosity variation, permeability changes, and the reservoir compartmentalization, which is the meaning is graded bedding may lead to a comparison between the reservoirs where different layers exhibits distinct porosity and permeability characterized. This can affect fluid connectivity and the reservoir behavior. The following point is the mud crack. Mud crack are polygonal patterns of that form on the surface of the fine grained sedimentary rocks such as mudstones or shale as a result of desiccating or drying. Example are lake bed and playa environment, tidal falls and desert environment. It's significantly in indicating that uh, desiccation features, which is provide a clear evidence of desiccating and indicating that the sedimentary surface has undergo drying. Next is polygonal pattern, and also the next point is directional feature. Next point is regarding the importance of the depositional environment, such as paleogeographic reconstruction, which indicates to past environment and spatial distribution and identification of ancient landscape. Next is the Paleocene climatology insight, which is related to climate dependent features and identifying the climate zone and seasonal variation. While there is another one more point, which is the chronological records, which is the stratigraphical sequence and the cyclical pattern. Next point is the diagenetic process. Uh, Diagenetic refers to the physical and chemical changes that sedimentary undergoes after deposition, but before they become a lithified rock. The impact of the dinosaur on the sedimentary structures are such as cementation, compaction, mineral replacement. They influence the sedimentation influence give an impact on the reservoir quality as can reduce overall porosity by filling the pore spaces between grains, while compactation is decreases porosity and increases rock density and potential, reducing fluid storage capacity and permeability. Next is mineral replacement, which is influencing uh, the original minerals with new ones can alter the rocks mechanical and chemical properties. Next is the hydrocarbon entrapment. This provide insight into the depositional history, diagnostic process, and fluid migration pathway within the sedimentary rock and influence the entrapment of the hydrocarbon. Hydrocarbon traps such as anticline faults, salt dome, stratigraphy traps, and unconformities. The last point of my presentation is the reservoir quality assessment. which is always get from the data synthetic, paleo environment reconstruction, and reservoir aesthetic architect understanding. The conclusion of my presentation is sedimentary structure are integral to reservoir quality assessment. Their analysis, when integrating with geological data and predictive modeling, empowers a reservoir professional to make informed decision, optimize production, and ensures sustainability and so extraction. Thank you. That's all for my presentation today.